Alrighty, so today we're going to talk about parabolas in terms of being a conic section. So it's going to look a little bit different than how we worked with parabolas in our quadratic functions unit. We are not only focused on functions anymore, we're going to have both vertical and horizontal parabolas. Okay? We're going to have both. So if you think about how we've approached every conic section, we kind of talked about how this set of points was created, how the curve was created. When we had a circle, it was the set of points that were the same distance from one fixed point, right? Or our circle. When we had an ellipse, it was the set of points whose sum of distances to two fixed points was constant. That was our string when we did that. Hyperbola was the difference of distances. So we got to kind of explore a parabola and see how this set of points is created. So you don't need to draw this. You can just kind of watch. What I've done is I've plotted a parabola on a grid, and I've denoted 2 point things in red. I've denoted the point 0, 1, and the line. What would the equation of this line be? Y equals -1. Yeah, good. Okay. So this point is fixed and this line is fixed, okay? And I've marked some points in green along the parabola. So I want to do a little bit of discussion about this. If I go from my vertex to this point, what's that distance? 1. And if I go from my vertex down to this line, what's that distance? 1. The same, right? Okay, look here. If I go from my parabola to my fixed point at this next dot, what's my distance? 2. And if I go down to my line, what's my distance? 2. You have to measure a distance from a point to a line perpendicularly. So I couldn't have drawn like all the way over here. I have to go perpendicular to the line. What if I did this point? What would the distance to the fixed point be? 2, and down to the line, 2. Okay, let's talk about this point up here. If I want to find the distance from this point to my red dot, what could I do? Yeah, I could do my Pythagorean, and I could do a distance formula, or I think a little bit easier, I could do Pythagorean theorem. Okay, how many units is my vertical leg? 3. And my horizontal leg? 4, which makes this diagonal 5. So that's a distance of 5 units. How far do you think it's going to be down to the line then? 5 units. See that? So on any point I picked, it doesn't have to be that I strategically picked points we could calculate easily, right? But I could have picked any point on my parabola, and the distance to this fixed point and the distance to this line would be the exact same. Yeah. To create, because that's what created this parabola. Okay, so give me just 1 second. I think it'll be clear. These points on this parabola are created because they are equidistant to this fixed point and this fixed line. Okay, this fixed point is called, what do you think? What have our fixed points been? Focus. Yeah, this is our focus. And this line is something new because we've only done fixed points so far. Focal. This is what we call a directrix. All right. So I'm erasing this, sorry, for when I come back in a minute. Okay, so let's define our parabola. Our parabola is the set of all points equidistant to a fixed point, and we call that fixed point the focus point, and a fixed line called the directrix. The set of all points equidistant to a fixed point called the focus and a fixed line called the directrix. All right, we've talked about lots of real-world applications of a parabola. What are some that you can think of?
Satellite.
Trajectory. The water and how.
Okay, trajectory path, how water comes out of a fountain. What'd you say?
Satellites.
Satellite dish.
A porpoise.
Okay. A what?
A porpoise.
A porpoise.
You know, whenever the.
Oh, the jump of the whales. Yeah. Okay.
You're direct.
All right. Directrix.
If your directrix just one under, where
We got it.
it's not that simple.
No.
Porpoise a whale or a dolphin?
I think it's like the
I don't know. Okay, so hopefully you wrote down some of your real world examples. Okay. How is a parabola created with an intersection of a cone and a plane? Okay, in a specific angle though. It's got to be what?
Like is it something like that?
Yeah, the same angle. So it's going to be parallel to your lateral face. The plane intersects the cone parallel to the lateral edge. All right, you should have your pink formula chart out. We're learning a new conic section, so you need to be referring to that. So if you look at your formula chart, you'll see that our equations look pretty different than the ones that we've used in the past. Okay? In a parabola, you only have one squared term. Either x is being squared or y is being squared. Think about the fact that when we studied quadratic functions, it was always y equals x squared, right? That was our parent function. So whenever your x variable is being squared, that's when you have a vertical parabola, because that's what we're used to, okay? So when your x variable is being squared, it's a vertical parabola. When your y variable is being squared, that's weird and different. Those are the horizontal parabolas, okay? So to tell which direction your parabola is open, you're going to look at this number right here, this 4 times p. We'll talk about what p is in just a second, okay? But if this value right here is positive, you're going to open in the positive direction. So for a vertical parabola, opening positively would mean opening up, right? And for a horizontal parabola, which way would be positive, you think? To the right. If this value is negative, you would open down or left. Okay? I wouldn't waste your time memorizing these. Don't necessarily cross them out, but I wouldn't waste my time memorizing these. I'm not going to sit here and think, okay, K plus P and blah, blah, blah. I'm going to do it all based off my picture. So don't worry too much about these guys, okay? Now, this P value is new. If you take the absolute value of P, it is the distance from the vertex to the focus, or the vertex to the directrix. Okay, so I'm going to go back to that first example we had. From my vertex to my focus, and from my vertex to my directrix was 1. So what that means is that P in this example was 1. Okay? All right. You've got the axis of symmetry, because we know parabolas have symmetry. They always go through your focus and through your directrix, or sorry, through your focus and through your vertex. And the axis of symmetry and the directrix are always perpendicular. One's always horizontal and the other one's always vertical. Okay. All right. One other special thing on here that you don't necessarily have written on, so you might want to add, is called the focal width or the length of the focal chord. And that is equal to the absolute value of 4 times p, which was already given to you, right? 4p is part of your equation. So what that's going to do is that's going to help us plot a couple easy points. What the focal width is the width of the parabola through the focus. That's what that means. The width of the parabola through the focus. So I could get endpoints of the focal chord to give me 2 other points. So look at our first example. P was 4, right? So if I want to find my focal width, I would do 4 times my p-value, which in this case was 1, which gives me 4. So that means through the focus, my width of my parabola is 2. Or sorry, it's 4. Which means 2 to the left gave me a point, and 2 to the right gave me a point. That's how you're going to find your other 2 points to draw your graph with. Okay? Okay. As with all the other conic sections, this is going to make more sense when we actually do it. So let's try it. Okay? So, look at example 1. For each parabola, we're going to find the vertex, axis of symmetry, focus, directrix, and then we're going to graph. So, x minus 4 squared equals 8 times y minus 1. So, the first thing you do is you decide if this is a horizontal or vertical. And we do this by looking at whichever term is being squared. Is x being squared or y? X. So when x is squared, is that horizontal or vertical? Vertical. Because remember, we're used to x being squared, right? Y equals x squared. It's going to open up or down. Let's think. To determine if this opens up or down, we have to look at the 4p value, this number right here. If this number is positive, it's going to open in the positive direction. If this number is negative, it's going to open negative. So which way is this going to open? Positive, which in a vertical parabola would be up. That's always your first few steps. You've got to determine what you're working with so that you know how to get there. Okay. It might help you to write out the general form of our horizontal parabola, which is x minus h squared equals 4p times y minus k. Just as you're kind of getting used to the pattern. Okay, so our vertex is always h, comma, k. So what would our vertex be? 4, comma, 1. Everyone okay with that? So I'm going to plot 4, 1 for my vertex. Okay. This is a vertical parabola, which means my axis of symmetry is going to also be vertical, right? So my axis of symmetry goes through my vertex in a vertical line. So what would the equation of that axis of symmetry be? X equals 4. Good. Everyone okay with that? Okay. Now we've got to find our focus. So the first thing you have to know is your focus is always inside your curve. So my focus is going to be somewhere in here. So let's get our p value. If 8 is equal to 4p, what is p going to be? 2. So based on my kind of little sketch here, I know I'm going to go to which direction to get my focus? Up. So I'm going to go 2 units up, and that's my focus. So my focus is at 4, 3. Everyone okay with that? All right, where's my directrix going to be? I'm going to go down from my vertex. How many? 2, but it's not a point, right? It's going to be a line, and it's going to be a horizontal line. So what's the equation of that directrix? Y equals -1. Okay, we're almost ready to draw in our parabola. We know it's going to look something like that, but I need 2 more points. I'm going to use the endpoints of the focal width, or the focal chord. Okay, remember we talked about that? So this 8, this 4p, that's the focal width.
So 0.
So what that means is that from my focus, the width of the parabola is 8, which means it has to be how many on each side? 4. So I'm going to go 4 units to the left of my focus and plot a point. And I'm going to go 4 units to the right of my focus and plot a point. Now I've got 3 points and I can sketch in my parabola. Questions? All right. Let's try another one. Y plus 1 squared equals negative 4 times x plus 3. Y plus 1 squared is equal to negative 4 times x plus 3. All right, first thing we determine is horizontal or vertical.
Vertical.
Think about which one's being squared.
Horizontal.
Your y is being squared, so this is horizontal. Is it going to open positively or negatively? Negative, because this value is negative. So the negative horizontal direction would be to the left. I find drawing these little mini sketches really, really helpful because it kind of lets me see which one's going to be horizontal, which one's going to be vertical. It just kind of gives me an idea. I'm not saying you have to, I'm just saying it's gonna help you. Okay? Yeah.
Wait, why does it open to the left?
Because it opens to the left because this 4p value is negative. And when this number is negative, you're going to open in the negative direction. And for horizontal, that would be left. Okay? All right, if it helps you out, go ahead and jot down the equation under here. Y minus k squared equals 4p times x plus, or sorry, minus h squared. Or sorry, just minus h. Where is your vertex going to be? Very good. Negative 3, negative 1. You gotta go get the x value from the x binomial and the y value from the y binomial. So negative 3, negative 1. Okay. Think about this little picture you drew, right? That's why I draw it. Because if you just plot one point, you don't know how the axis of symmetry has to go. But if you kind of look up here, your axis of symmetry has to go horizontally, right? So what would the equation of your axis of symmetry be? Y equals negative 1. Okay there? All right, let's plot our focus and our directrix. So I know negative 4 is equal to 4p, which tells me p is equal to negative 1. That negative acts as a direction to get to my focus. So instead of going 1 unit to the right, which would put my focus out here, I have to go inside my parabola. So I have to go 1 unit to the left, which puts me at what ordered pair? Negative 4, negative 1. So where would the directrix be? Negative 2, but we have to give it as an equation. Good, it's a vertical line, so x equals negative 2. We use our p-value. So our p-value is the distance from the vertex to the focus. So I went for my vertex and I counted 1 unit inside my picture, basically, inside my parabola to get my focus. Okay, we're almost ready to sketch our parabola. We've got to get our 2 other points. We're going to use the endpoints of our focal chord. What's the total length of my focal chord? Okay, we use the absolute value, so 4, right? Which means from your focus, the width has to be 4, so we're going to go up 2 and down 2. Okay? All right. Write down number 3, please. Okay. Right here, you should be able to tell 2 things. The first thing is you should be able to tell that this is a parabola. The way you tell this is a parabola is there is only one squared term. Do you see that? There's only an x squared. In all our other conic sections, circle, ellipse, and hyperbola, the x squared, there was x squared and y squared. Okay? So I know it's a parabola, and I know that it is a vertical parabola. The reason I know it's a vertical parabola is because x is what's being squared. When x is squared, you have a vertical parabola. Everyone okay with that? Okay. We got to get it into standard form, though. So it's always important to know what your goal is. So look at the equation of all your vertical parabolas on your formula chart. They should always be set up. X minus h squared equals 4p times y minus k squared. So that's our goal. So how many times are we going to have to complete the square? Just once, because I'm only trying to create one squared binomial. And that binomial is using x.
Doesn't y 0? Y 0?
No. Okay, so let's take our x values and keep them on the left. So I'm going to have 2x squared. Well, sorry, wait. Before I do that, sorry. What do you notice about all these values? They're all divisible by 2. Okay? It's not that you're going to pull out a common factor. It's that you can go ahead and just divide everything. Okay? Because this is an equation. It's equal to 0. So whatever I do on the left, I can do to the right. If you're able to do that, do it if it helps you. To me, I always would rather use smaller numbers if I can. You do not have to, though. And you don't always do it. You only do it if it makes things better. Okay, sorry about that. Now we want to get all the x stuff on the right, on the left, and all the other stuff on the right. I'm going to have x squared minus 2x. I'm going to leave a blank to complete the square. Is equal to, move my 4y, so negative 4y plus 3, and my blank to counteract. All right, so my b value is negative 2. Half it, and you get negative 1. Box it, square it, and you get 1. I'm going to add 1 here, and I'm going to add 1 here. All right, so that gives me x what? Minus 1 squared is equal to negative 4 y what? Plus 4. Okay, compare your goal. This was our goal, right? This is where we were trying to get to what we have. Are we done yet? No. Notice that you have to have y minus a number or y plus a number in here. Okay? So we have to pull out whatever coefficient of y we have. Here it's a negative 4. So we're going to have x minus 1 squared is equal to negative 4 times what? Y minus 1. Good. There's the equation of our parabola. Everyone okay with that? Okay. Now we already know it's vertical. Now we have to decide, does it open up or down? Down. How do we know? Yeah, this negative right here. Okay, where's your vertex going to be? 1, 1. Good. Okay, now your axis of symmetry is going to be vertical, right? This is a vertical parabola, so what's my axis of symmetry? X equals 1. All right, let's get our focus. So my -4 is equal to 4p, which tells me that p is equal to what? -1. That negative is like a direction, okay? So that negative tells me I'm going to go down 1 unit from my vertex. So here I'm going to go down 1 unit. And what's the location of that focus? 1, 0. Everyone okay? Where's the directrix going to be? Okay, except that it's a line. Y equals 2. Good. It's not just an ordered pair. So your vertex and your focus are always points. Your directrix and your axis of symmetry are always lines. Okay, we're almost done. We need the endpoints of our focal chord. So how do I do that? Yeah, so we take our 4p, which in this case is 4, and I go 2 units in either direction from what point? From the focus, because it's a focus chord or a focal width. Wait, I went 3. Sorry. There we go. Could I like plug 3 in here, 3, 0, and see if it works? To see if I plotted a correct point? Yeah. If you're not sure about that focal width thing, try it. Plug a point or 2 in and make sure you did it correctly. No, I would just say, okay, if I plug in 3 for x and 0 for y, am I going to get equivalent statements on either side? Okay. All right. Y squared minus 4y plus 12x minus 8. Horizontal or vertical? Horizontal, because y is being squared. Good. All right, so what's your goal for a horizontal parabola? Good. So it's good to know what your goal is. Okay? So I'm going to keep my y values on this side. So y squared minus 4y. And they're going to go to the other side. Negative 12x plus 8. All right. I want you to give that a try. I want you to complete your square and try and come up with your information. All right. What should you have gotten for your equation? Good. Everyone okay on that? Which way is this going to open?
Left.
Good. Horizontal. So your options are left or right. This is a negative 12, so I'm going to open left. Okay, try and fill in this information. And sketch your graph. talk it out with each other, get some help. Of all the conics, I think this one is the hardest to do without drawing. I have to draw my parabolas out. There's no way I can come up with it without. So don't try and take too many shortcuts. It'll mess you up. While you're working, I'm going to pass out your quizzes, but you must keep working. You must finish this problem, okay? You're coming up with these 4 pieces and you are graphing. All right, let's talk about it. Your vertex is located where? 1, 2. Which means your axis of symmetry is y = 2. If negative 12 is equal to 4p, p is, and that negative just means we're going to go inside of my parabola, inside here. So to the left 3, putting me at negative 2, 2. Where's your directrix? 3 units on the other side, good. Which is x = 4. All right, how long is your focal chord? 12.
Oh.
So what that means is we go up 6 and down 6 to get my other 2 points. There's your parabola. Okay? A little heads up about what's coming up. On Monday, we don't have school. On Tuesday, we will do our second day of parabolas. And on Wednesday, you have a quiz over hyperbolas and parabolas. It will look very, very similar to the quiz you just got back, so you know what to expect. Okay? Now,